Why is the universe always dark, despite trillions of stars? A dazzling paradox. Can't all those stars light up the entire universe? This seemingly simple question actually hides one of the deepest mysteries of the cosmos. If the universe were the way we once imagined it for hundreds of years, then right now, the night sky above you would never be dark. It should be filled with brilliant white light, like standing in an endless forest. No matter which direction you look, your line of sight would always end on a tree. In 1823, the German astronomer Heinrich Wilhelm Olbers raised this very question. He formally presented this paradox. In an infinite, uniform, and static universe, if enough time has passed, then from any direction on Earth, the sky should be completely filled with bright stars. Every line of sight should end on a star. But in reality, although we can see starlight in the sky, the night sky is mostly dark. This is known as the dark night sky paradox. Heinrich Wilhelm Olbers tried to explain it. He suggested that interstellar dust absorbs visible light, dimming distant stars. But this explanation is incomplete. Dust can block some light, but it also heats up and eventually re-emits that energy. The sky should still appear bright in an infinite, static universe. Dust will continue to heat up and re-radiate that energy until it reaches thermal equilibrium. In that case, the night sky should still be bright. So he concluded that in an infinite, uniform, and static universe, at least one of these assumptions must be wrong. First, is a universe really uniform? To the naked eye, the distribution of stars appears uneven. They cluster into star groups and galaxies. But when we zoom out, to scales of hundreds of millions of light years, the picture changes completely. To test this large-scale uniformity, the Hubble Space Telescope spent 16 years, pointing its camera again and again at a tiny region of sky that appeared completely dark. In this long observation, it collected thousands of exposures. The total observation time reached about 250 days. In the end, multiple teams of astronomers combined the data to create a single image, the famous deep field. In this high-resolution picture, even the faintest point of light is a galaxy. It pushed the limits of human vision, revealing billions of galaxies in a single image. In a patch of sky no larger than the moon, there are about 265,000 galaxies. Observations from the Hubble Space Telescope have strongly confirmed that on the largest scales, the universe is remarkably uniform. Since the assumption of uniformity appears to be correct, then the problem must lie elsewhere, in infinity, or in the idea of a static universe. If the universe were truly infinite, with infinite space and infinite time, then every line of sight should end on a star, and the night sky should be completely bright. The dark night sky is actually easy to explain, because stars are finite. They cannot fill an infinite universe. Modern observations show that the universe was born about 13.8 billion years ago in the Big Bang. This is very different from an infinite past, and the speed of light is the ultimate speed limit in the universe. Because of this, the part of the universe we can see is limited. If a star is more than 13.8 billion light years away, even if its light started traveling toward us, from the moment it was born, it still hasn't had enough time to reach our eyes. That light is still on its way. We are essentially trapped inside a region of space with a limited radius, the so-called observable universe. Although 13.8 billion years sounds unimaginably vast to us, in physics, it simply means there is a limit to how far light has been able to travel to reach us. But even this is not enough to fully explain the problem. The number of stars is still unimaginably large, and the total energy they produce should be enough to make the sky bright. To make the sky truly bright, we need to test the third assumption. Is the universe static? In the early 20th century, the astronomer Edwin Hubble observed a remarkable phenomenon. He discovered that the light from distant galaxies is shifted toward the red, a phenomenon known as redshift. This discovery shows that the universe is expanding like a balloon, and on the largest scales, space itself can expand faster than the speed of light. As light travels from distant galaxies, through this expanding space, its wavelength gets stretched. Light that was originally visible to the naked eye, after traveling tens of billions of light years, has shifted into extremely low energy infrared radiation, and even into microwaves with extremely long wavelengths. This is another reason why the night sky appears dark. This stretching of spacetime not only dims the light, it is as if it has erased the light. Interestingly, Heinrich Wilhelm Olbers' idea was, in a sense, correct. If you could set aside the limitations of human vision and had eyes that could see microwaves, you would find that the night sky is never truly dark. The universe is filled with an extremely uniform faint white glow, spread evenly in every direction. This is the famous cosmic microwave background radiation. It was released about 380,000 years after the Big Bang, when photons first broke free from matter and began traveling freely through space. It is the first light of the universe. After more than 13 billion years of expansion, and after cooling, its temperature has dropped to just above absolute zero. This faint residual radiation is still all around you, about to 0.7 degrees Kelvin, even right now. Signals from billions of years ago are passing through your body. If you still have an old black and white TV and switch to a channel with no signal, those flickering snowflakes on the screen, about 1% of it, comes directly from the afterglow of the birth of the universe. Night is not the opposite of light. It is simply light that has been extremely diluted by the expansion of the universe stretched to its limit. When Heinrich Wilhelm Olbers died in 1840, he probably did not expect that the mystery of the dark night sky that puzzled him would only be explained a century later by the Big Bang Theory. This theory challenged our old idea of a static universe through the simple phenomenon of night. It reveals the deepest workings of the cosmos. The universe has a beginning and it is expanding. It limits what we can see and stretches the light from distant stars. Darkness is not nothingness. It is light delayed by time and from a future that has not yet arrived. It is the universe's deepest gift. Two intelligent beings